Hey there, year 11s. We are now going to find do a bit of an application, but really, hopefully, you've understood a lot of the theory. So here it says for the curve determined by the rule. So this is your curve. This is your f of x. That's the function. It's a cubic function, right? They want you to find the gradient of the tangent line. So remember, to find the gradient, the tangent line is y equals to mx plus c. What they want you to do is to find m. And remember, you can find m, and this point here, they say at the point x equals 1, negative 2. So if we had to picture this graph, I don't know what the x cubed looks like, but let's just say it looks like this, hypothetically, right? So this is I'm just making it up. If at x equals 1, hypothetically, if 1 was here, so this is the point, 1, negative 2, right? So this is 1, negative 2. All they're asking you to do right now is there must be a tangent line that touches this point only once, okay? And that tangent line is your y equals mx plus c. They want you to find the gradient. So they want you to find m for that line, okay, if you know it's 1, negative 2. So how do you do that? Remember, because you're finding the gradient at one point, you can use first principles, or if you can use any shortcuts to differentiate it. So right now you've got f of x is equal to 3x cubed minus 6x squared plus 1. To find the derivative, because the derivative is the gradient. Remember that. It's the it helps you find the gradient at one point. So I need to find the derivative equation first. So the derivative, I can use first principles, but in this case, I can see it's a power rule because that's x cubed, this is x squared, and that's 1. So I know I can differentiate them. And using the power rule, I can differentiate each term. And here we go. The 3 doesn't get affected, but the x cubed, when you differentiate it, it becomes 3x squared. Minus, again, the 6 doesn't change, but I'm differentiating the x squared, which is 2x. And then we know that derivative 1 is going to be 0. Okay, you can test it again if you don't believe me. 9x squared minus 12x is what my derivative is. So this is what f dash of x is. Remember, this is your gradient function. This only allows you to find out the gradient at any point on your particular curve. But we do have a point that we're interested in. We're interested in when x is equal to 1. So at x equals to 1, then the derivative of 1, meaning find the gradient when x equals 1, is going to be 9 times 1 squared minus 12 times 1. That really just becomes 9 minus 12, which is negative 3. So what all that calculation just now has done for you is that it told you m is negative 3. Okay, so obviously the diagram I just drew doesn't make sense because clearly my diagram is showing it's a positive gradient. But that's what I was saying before. I was saying it doesn't matter. I'm just drawing it so you can kind of visualize it. If you want it to be accurate, this is what it should look like. Okay, so I would go back and use Desmos. Let's go. Do I have a Desmos here with me? Not at the moment. Let's go Desmos, graphing calculator. Here we go. Let's actually look at what it looks like here. So our equation is 3x cubed minus 6x squared plus 1. So 3 f of x equals to 3x cubed minus 6x squared plus 1. I think that's what it was. Yep. Okay, so this is my graph, right? And they're saying this is the point, 1, negative 2. So that's where it is. So I'm going to just copy this so that we can see what it looks like over here. So I'm just going to graph it so you can see. And I'm just going to put it in so you can visualize what we've been doing. So here we go. I'm just going to put this here. And let's zoom in again. So what they gave you was 1, negative 2. This is the spot. This is the sweet spot of 1, negative 2. Then you had a tangent line that crosses that point once, touches that point once. Okay, so I'm just going to try to draw it so it looks like it's touching it. Here we go. That's my tangent line, right? And that tangent line has a y equals to mx plus c. So because you're trying to find the gradient, okay, of that tangent line, and you only got one point, that's when we're using first principles or power rule, because this one is a power function. So we can use a power rule shortcut to find the derivative function, so this over here is the gradient function. Okay, so it only tells you, this function only allows you to find the gradient of any point on this curve. And specifically, we want to know at x equals 1. So we found out that the derivative when x equals 1 is negative 3. So that just means that m is negative 3. So what we're saying there is it's a negative 3 gradient. That's what they're saying. And that makes sense because clearly, look at the gradient. It is a negative line. So that makes sense. Okay, so that's what I'm trying to say. Trying to picture it in that way. And exercise chapter 18 will only get you to find C. And how do you find C? Well, this line only has one point that we know, which is 1, negative 2. You would sub x equals 1 and y equals negative 2 to solve for C. And that's chapter 18. Part of chapter 18 anyway. Okay, so really try to picture it and really try to understand it from that point of view. Hopefully that helps. I'm just going to delete that. And let's delete that. Cool. That should be it.